everybody, and welcome to our presentation on exploring supervolcanoes as an existential risk. So, to begin, I would like you to meet Edda. Edda is a 10-year-old girl from Iceland. She will be popping up throughout this presentation, so keep an eye out. An outline of the presentation today: we will begin with a case study, we'll move on to what counts as a supervolcano and how common they are. We will then move on to the causal mechanisms by which supervolcanoes could actually cause our extinction, and then we'll move on to how often have supervolcano eruptions occurred in the past and what were the consequences. Next, we will turn to how large we estimate this extinction risk to be in this decade or the next century. We will then move on to can the risk be mitigated or eliminated, and we will follow with the conclusion. So, Edda would like you to learn some common volcanic terms that will be used throughout the presentation. To begin with, we have, what is a volcano? It is a rupture in the ground that allows magma to escape to the surface. What is magma? It is a rock beneath the Earth's surface that is so hot it has melted. Lava is magma that has reached the surface. And VEI is volcanic explosivity index. Next, we have how to describe a volcano. So active, an active volcano is one that erupts regularly. Dormant is a volcano that has not erupted in a long time, but it's expected it might in the future. And extinct is a volcano that has long gone, and it's a result of the magma chamber solidifying. And ash is the tiny pieces of solidified magma that have erupted from the volcano. So, welcome to Grindavik. With a population of 3,000 people, it is the largest city in the southern peninsula in Iceland. It is one of the most popular cities to visit in Iceland. It is situated on the coast, therefore it has a really nice connection to the water, the Atlantic Ocean, and it is historically a fishing town. It thrives off tourism, as many people come here to visit the hot baths and things like this, and it has a diverse landscape including volcanic features. Its economy is doing well, so it sounds like an okay place to live. However,
a volcano in southwestern Iceland has erupted for a third time since December. The eruption began at 6 a.m. local time, soon after an intense burst of seismic activity. Now, jets of lava rocketed into the sky, triggering an evacuation of the Blue Lagoon Spa, one of the island nation's biggest tourist attractions. The Icelandic Meteorological Office said that lava was flowing to the west, and there was no immediate threat to a major power plant in the area.
So this eruption is similar to the December 18th eruption. It's in the same general area. It's further from Grindavik compared to the 14th of January. But the problem here is the lava is flowing towards west, and it flowed over the road already, leading to Grindavik, and it's now heading towards the hot water pipes in the area. The lava actually flowed over the road, and it's heading towards the hot water pipes supplying hot water to the general Reykjanes area. So that's serious news. Around the Svartsengi power plant, dikes were already in place, but the problem is, of course, there are hot water pipes leading from the power plant to the users. And those pipes are in great danger now. Well, it's a bit early to say if the eruption is already waning, but the progress of the lava front has been really rapid this time. It of course also depends on the topography in the area, and it's quite rapid progress.
So, to reiterate on what has happened in Grindavik, in November 10th, 2023, after extreme and escalating seismic activity, a state of emergency was declared on the town, and they were forced to evacuate. A few days later, they were allowed to return briefly just to collect pets, essential belongings, as experts were warning that this volcano may erupt. On December 18th, the first eruption occurred, and they had to leave their homes. At the beginning of January, some dared to move home. However, they had to leave again on before January 14th of this year, as there was a second eruption. And just last Thursday, it was the third consecutive eruption. So, Edda had to say goodbye. Her life took a dramatic turn as the volcano erupted. It casted a shadow over her once serene town. She was forced to leave her home and everything she knew behind. Edda embarked on a journey of uncertainty with her family. She saying bye to her school life and everything in Grindavik, not knowing when or if she would ever be back. So, moving on, when discussing the existential risk of a supervolcano, it is important to understand what exactly a supervolcano is. So, a supervolcano is one that has a volcanic eruption of magnitude 8 on the volcanic eruption index scale, which we previously discussed. When a volcanic eruption occurs, it ejects more than 1,000 cubic kilometers of material, and it produces calders which are often wider than 50 kilometers, which is massive. To look at the anatomy of a supervolcano, so the magma chamber is deep down, and the caldera is what I just mentioned. It's like this crater that happens because of it, and this is all of the elements and the material that erupts. So another diagram of what a caldera looks like after the volcano has erupted. There's a crater left as there is space underneath the Earth's surface. To understand the enormous scale of how big a supervolcanic eruption is, there is a comparison scale here. The closest thing that ever has happened in recent times was the eruption of Pinatubo in the Philippines in 1991, which is this tiny green dot here. So this had a VEI index of 6. However, this is 100 times smaller than the benchmark for a supervolcano. Yes, okay. How common really are supervolcanoes? So there is about 1,000 volcanoes in the world, and 20% of these volcanoes are super. This map dots the volcanic supervolcanoes around the world. The red is a VEI of 8 and the orange VEI of 7. The closest thing to our supervolcano was Yellowstone, which erupted 3 times over 2.1 million years, and this is in Wyoming in the US. You would say that they are not common, as only 2% of the entire volcanoes in the world are super. However, just one of these supervolcanoes could pose an existential risk, as they are so much more deadly than a regular volcano. A fun fact is that Mount Vesuvius was the earliest described volcanic eruption, and everyone knows the severe impacts that happened in Pompeii, killing many, many people, and that was in March 17th of 1944. What is the causal mechanisms by which supervolcanoes could actually cause our extinction? So, for a supervolcano to cause extinction, it would basically have to be hand in hand with how the direct results occur to humanity, but also just how it would interfere with the Earth's climate. To start, there is pyroclastic flows, which is the flow of the matter which comes out of the supervolcano. This would incinerate anything in its path. It would just completely destroy cities and nature nearby, as it is so hot. There would also be ash and particle emissions. These are so intense that it could cause a volcanic winter, and the whole Earth would be dark. And this would block the sunlight, which meaning there would be a drop in global temperatures. There would be a extreme release of sulfur dioxide gas, and this combined with what is already in the Earth's atmosphere would create sulfate aerosols, and this would reflect the sunlight and cool the Earth's surface even more. So the combination of these two would cause prolonged darkness and cold temperatures, and this would result probably in a famine, as food chains would run out in around 8 weeks. 8 weeks, and there would be complete biodiversity loss, as things do not function without sunlight. Moving on to a comparison of the energy scale. So the eruption of a supervolcano can release on the order of 10 to the power of 15 to 10 to the power of 17 joules of energy. This is quite a bit less when you look at a nuclear explosion, which would release 10 to the power of 13 joules of energy. And this would be on a VEI scale 5, equivalent to 1,600 times the size of the atomic bomb which dropped on Hiroshima, which caused an entire loss of life. So this in terms of what human civilization uses up annually, we use 4.6 times 10 to the power of 20 joules. So it is a colossal amount in terms of energy. However, it is seemed to be sort of minimal when you compare it to just how much energy we use as a population. In summary, the extinction level threat from supervolcanoes lies in their capacity to alter the Earth's climate on a global scale, so it would truly affect everywhere on Earth. Supervolcano eruptions are huge in geological terms, as I mentioned. However, they are small compared to the human consumption. So, Anna's back. She may not be able to live in Grindavik for a while, but there is still hope in terms of mitigating this problem, as it is very uncommon that a supervolcano will wipe us out. So, how often have supervolcanoes erupted in the past? And what have been these consequences? So, how often have they occurred? No one alive has ever witnessed a supervolcanic eruption, or for generations back, for that matter. The last time Yellowstone erupted, which is the most common cluster of supervolcanoes, was 640,000 years ago. The interval of these eruptions of supervolcanoes is 100,000 years, and the last one was over 26,000 years ago, so a long, long time. As you can see, this is the scale again. So, like the Yellowstone 2.1 million years ago, long, long time ago, there were 2 in the 20th century. 3. So yeah, it's not very common at all. The consequences of these were lasting earthquakes that shock the ground, as the Earth's surface usually cracks and causes this. There's molten rocks and matter blasted into the air, which can contribute to the pyroclastic flow, which we discussed. The clouds of gas and rocks destroy the surrounding areas and pollute the air, and this plunges the world into a volcanic winter. How large do we estimate the extinction risk by supervolcanoes in the next decade or this century? Personally, we predict it to not happen, under 0.0001% prediction of this happening. For an extinction to occur, it wouldn't just have to be one supervolcanic eruption, but it would have to be multiple at the same time. And even if one erupted, it would probably leave some people left over to survive, and these people would embark in a famine. As we previously discussed, there would be a ash and cloud winter, which would have no sunlight. Nothing like this has ever happened before that we have record of, so we cannot really predict how the survivors of a supervolcanic eruption would exist. So, can the risk be mitigated or eliminated? Yes. They are trying. So, drilling holes into the volcano, an effort to try and cool down this magma chamber. So, by drilling holes, you give somewhere for the hot air to release, so that it doesn't really build up as much. They also monitor it a lot. There's volcanologists, I think, volcanologists, something like that, who look for signs of potential eruptions, and their whole life is to just predict what may happen next, such as in Grindavik, and it is a work in progress. So as with every existential risk there is in the world right now, there are people continuously working on solutions to mitigate these chances of eruptions. Do not worry. So let's move on to a quick video.
There's a volcano beneath Yellowstone National Park, powers 6 industrial power plants. About 60 to 70% of that heat escapes through hot springs and geysers like Old Faithful. But the rest stays underground, inside the supervolcano's magma chambers. And it's here that the scientists staged the attack. In this scenario, they proposed to drill a series of wells around the perimeter of the supervolcano. The wells would be some of the deepest in the world, reaching up to 10 kilometers below the surface. They pump cold water down into the wells, which over time would cool a ring of rock around the magma chamber. Sort of like how coolant in your car carries heat away from its engine. In bonus, the water is heated to around 340 degrees Celsius as it moves through the chamber. So the plan is to loop it back through the wells and use it to drive an electric generator, which could power the surrounding area for tens of thousands of years, essentially transforming Yellowstone into a giant geothermal power station, and ultimately paying for itself in the end. The scientists concluded that yes, in theory, this could work. But would we ever actually try it? Probably not. For one thing, you'd have to extract 20 gigawatts of energy to cool the volcano down to a safe temperature, which would take an estimated 16,000 years from start to finish. Not to mention, the plan would cost $3.46 billion. That's about 20% of NASA's annual budget. Even worse, cooling the rock could create fractures near the magma chamber, which might trigger a super eruption, the very thing we're trying to avoid in the first place. But lucky for us, the volcano is still sleeping, and probably will be for a while.
So, as they explained, there is solutions that could be used if they were to predict that this supervolcano may erupt in the next thousands of years. However, they're expensive and they are timely. And as the supervolcanoes are all basically dormant, they have not really instigated these plans yet. So, to conclude, as we witnessed the evacuation of Grindavik, this small town in Iceland, we were confronted with the harsh reality of an immediate threat caused by volcanoes. This localized event served as a poignant foreshadowing for a larger, more existential risk that these supervolcanoes may have for our planet. Imagine if such eruptions were not an isolated incident, but however, on a global scale. This evacuation, while distressing in its own right, is a small hint of what may unfold if volcanoes were to awaken simultaneously across different parts of the world. Understanding and preparing for these situations is crucial for our collective resilience. However, as we have heard many times, these volcanoes are not predicted to erupt in our lifetime, our great-grandchildren's lifetime, or many, many hundreds and thousands of years for that matter. Thank you very much for your attention. Please feel free to ask any questions or add any comments or discussions if you have any. And these are our sources we used.